And hello, welcome everyone to this video. I'm just doing a documentation recording of how to install Labview. Not just Labview, but the control design and simulation part of Labview into OpenSUSE. Okay. Now, what you must have available are your OpenSUSE. You should have at least a virtual machine installed of OpenSUSE, and that's what I have. Okay, and you also need your Labview. Okay, so this is a fresh install of OpenSUSE Tumbleweed. So let me try neofetch. So there's no neofetch here, so I can just do sudo zipper install neofetch. Okay. Why I'm doing this, I'm just showing you what operating system that is. You don't really need to do this part to get Labview working. Okay, so ideally you will have your OpenSUSE, your ISOs ready for Labview, as well as the control design and simulation. Okay, for me, I have them in a thumb drive like this. Okay, and what you need to do also, now if you have them on your main operating system, in this case I have Linux. I'm using Manjaro Linux on for my main operating system, and of course OpenSUSE Tumbleweed. There's this very nice infinity sign. OpenSUSE Tumbleweed for this virtual machine. Why I like Tumbleweed? Well, if you can tell by now, I sort of the arch mentality of rolling release distro. That's kind of caught on me. So okay, what you need to do is just before you start, it's always good to ensure that you have your Spice tools installed. Okay, so let's just make sure that your Spice tools are installed. Okay, so here is where you should check for your Spice tools. So under guest, you should have your Spice VD agent. Okay, so let's see OpenSUSE VD agent. So how do you install it? Okay, you can't really just direct install here for the Spice VD agent, because it may or may not work for this Jest for Tumbleweed. But what you can do is this. Okay, so what you do is sudo zipper install. So instead of apt, you use zipper for Tumbleweed. VD Spice VD agent. Okay, so it says Spice VD agent's already installed, so that's no problem. Okay, the next thing you need to do is to find this XF86 Xorg server. So let's see OpenSUSE Xorg server Spice. So there should be this XF86 video queue XL. Sorry, yeah, XF86 video queue XL. That's the correct one that you're looking for. You look at this one, XF86 video queue XL. Why are we doing this? Is to help your virtual machine run a bit smoother. If you're not using virtual machines, then you can just skip this part. So whatever this is here, XF86 video queue XL. So sudo zipper install XF86 QXL. Okay, already installed. Why is this important? Why is it important to do two of these? It's to make your transition between your main OS and your OpenSUSE OS in the virtual machine very much smoother. So that one of the good things is that you can just copy and paste over your ISOs from your main OS into your OpenSUSE OS, just like that, just drag and drop. Okay, very fast. Of course, another thing I like to do is to change my display, because this is a very small one. Let's do 1600 by 900 and I'll apply. I'll keep this configuration, and this is a very nice, very much nicer way. Okay, so I'm using OpenSUSE XFCE, but you can just do KDE and all that as well. Very simple. Okay, how do we install Labview? Okay, so now you should have your Labview full Linux ISO. Normally it comes pre-packaged with a Mac in a sort of a combination ISO. You have to take this Labview ISO out, and this part is pretty simple and straightforward. Okay, you have to mount this ISO. All you have to do is just to double click. Okay, all you have to do is just to double click this Labview 2020 full Linux ISO, and here you go. Very simple. All your files that are needed are here. Next, what you then need to do is to install. Okay, how do you install? Okay, there are no actual instructions that are that, I mean, there are instructions, but they're not that intuitive or easy to find. But you should know, I mean, as a Linux person, you should read this and get it like straight away. Okay, but I'll show you. Okay, it says insert and mount Labview installation media as root user in the mounted directory. Enter sh, and then you run the install script, and to install Labview into the user local directory. Okay, to install Labview models and toolkits, refer to README for each product for installation instructions. Okay, so I'm going to show you the control design and simulation one. Okay, but it's kind of a workaround-ish way, because this is Labview 2020, and the control and design simulation I have is 2018 version. So there will be some workaround that you kind of need to do. Okay, so I'm going to open the terminal here. I'm going to go into super user mode, or basically it's running as administrator. Okay, so now I've entered my password and I'm in super user mode, or maybe basically running as root or administrator. I'm going to type ls, and basically I just sh, as in using the shell script. I can just put install. Okay, make sure it's in capital letters because that's what the shell script is in. Sh install, just put yes to everything. Okay. Okay, yes. Okay, so it's very, very fast to install Labview. Okay, so next thing you'll need to do is while waiting, you can of course mount your control design and simulation, and then you can do one of the README here. Open the README. Okay, for the README, it just says you can install the control design simulation module using Labview 2018 media for OS, Mac OS or Linux. Refer to the Labview media README on it for installation instructions, which I don't really see it over here. Okay. Okay, or maybe it's in a text kind of thing, but where's the installation instruction? You can install, okay, basically it's the same thing. You have to refer to the media, which isn't very helpful. Okay, let's see whether there's other things here. Okay, so what I do is I went to the Linux folder, look at README. Okay, again the README installation instructions, they just tell you to refer to the README, which I think this is the README, so I don't understand. Okay, but one can kind of guess that the installation procedure is pretty similar to what you're doing here in Labview. Okay, so let's see, it's still running. Okay, so yeah, normally what you would do is wait for all of this to finish. You have to wait for all of this installation to finish before you install the 2018 control design and simulation modules. Okay, so the thing is this, there's an issue with this, because the control design and simulation module will normally look for Labview version 2018. Okay, because this control design and simulation module is meant for Labview 2018. However, we are running Labview 2020. Okay, or basically we are installing Labview 2020, which again is not helpful, in the sense that, all right, you have to do some manual labor. Okay, a little bit of manual tweaking here and there. But thankfully, one of the workarounds that you can do is basically just what do? Yeah, you just copy and paste some files over. It is that simple. Okay, just to get this thing working. Okay, so well, I let me check the manager, task manager. I don't know whether this thing is still working, or did the thing become frozen. Okay, CPU seems to be working a little bit. Yeah, I don't even know what's going on. Okay, yes. Okay, some cache file has been created successfully. Okay, so that's good. Okay, it's installing. Okay, so where will you find all of these files? Okay, alright, now Labview's installed. Where will you find all of these files? Okay, you go to your home directory, go up one level, go up another level. You should go to the user, go to local, okay, user local, go to National Instruments. Here you will find your Labview 2020. Okay, so now installation is complete, and I can just do a Control D to exit this thing, and well, I don't exit yet. Okay, I still want to use this terminal. But let's see whether Labview has been successfully installed. Yes, it has, so you can just add it to the desktop and take a look. Labview. Okay, so I can of course make a new VI, and here's the VI, and if I go here, and all the stuff is around. Okay, of course control and simulation doesn't have the full suite here, because I have not installed the control design and simulation part yet. So let me exit. Okay, maybe I'll exit this thing, because I want to open the terminal right here. Okay, so where I have my run media SUSE, my username, which I just call SUSE user, 2018 control design simulation, ML. I don't know what that stands for, like module or something. I'm not really sure. Is it module or no? If you know, just leave it in the comments. I have no time to figure this out. Oh, Mac and Linux. Okay, that makes sense. Okay, so this is Linux. Yeah, so let's open the terminal here. We can repeat the instructions. So I'll run as super user. Okay, so I'm in the root now, and now I can just type sh install. Okay, and I'll just click yes, yes, basically yes to everything. Okay, so when you have this license file, you don't really have to read it. Just press Q to quit. So accept the license, yes. So it will tell you this thing. Okay, Labview 2018 64-bit not detected. Do you want to manually specify a location for Labview 64-bit support files? So basically, where are you going to install all the control design simulation stuff? Okay, so I'm just going to install it close to my Labview 2020. Okay, so the default will be in user local. Okay, I won't change anything. I will just use the default. So I just press enter here, and we'll just continue pressing yes. Okay, so now you just wait for it to install. Okay, so we'll wait for it to install. It should be pretty fast. Okay, then it'll ask you whether you want to reboot. Okay, at this juncture, I will say no. I do not want to reboot yet. So normally you will have to reboot manually before this thing actually works. But well, since there's the problem of, you know, this Labview 2018 control design and simulation, you know, the file is not working because it doesn't detect the 2020 folder. You might need to do a little bit of extra work. And here's what you need to do. Okay, I spent some time to think about this. Okay, so what you need to do is, well, this is not the one you go for. You don't go to home SUSE user national instrument. You need to go to your binary, the bin file. Okay, wrong one, sorry. Go to your user, go to bin, or user local, sorry, user local, then go to national instruments. Now, if you installed it correctly, okay, on SUSE, OpenSUSE, I mean, Labview is meant for OpenSUSE lib, but OpenSUSE Tumbleweed will work pretty much just as well for the most part. Okay, so you see the main part of Labview is installed, so that's half the battle won. Unfortunately, your Labview control design simulation files are over here. What do you have here? VI library, templates, resource, readme, project, menus, manuals, help, examples, etc., and C code gen. Okay, again, this is not the same folder as this. But if you look here, you will see that a lot of the files are pretty similar. You have the VI library, you have templates, you have resource. Okay, what else do you have? Manuals, examples, help, etc. So you see etc., examples, and help. All of them are here. So that kind of makes you think, right? What's going on? How can we just copy and paste, right? Where are the files supposed to end up? So for example, the etc. files here, they are supposed to end up in the etc. folder over here, right? So that's generally the idea you do. Okay, unfortunately, there are lots of files to copy, so that may complicate things. Plus, of course, you want to make sure they all end up in the right folder. So the trick is not to do this manually. Okay, you just use the CPAR. Okay, copy the whole archive, so to speak. So in user local, okay, if you install the default directory national instrument, so okay, I'm using the XFCE desktop, so it's a very lightweight desktop, so that's why the terminal looks like this. It's not KDE. So over here you use the super user. Okay, so I'll log in as root, and now all you need to do is just CPAR your Labview 2018. Okay, all the files into Labview 2020-64. Okay, so now if you look at Labview 2020, you see the C code gen is in here. If you take a look at the etc., you should see the CD&Sim IMEF copied correctly. And not only that, you should also see maybe like in the VI library, there should be a CD&Sim. Okay, VI library, there should be add-ons, iMath, probes, and simulation. So look at the simulation, there is a simulation folder here. So basically what you've done is everything is copied correctly. What you have here should be yeah, a lot of libraries. Okay, I'm not going to elaborate on these. Okay, I'm gonna exit, and I'm gonna exit again, and of course before I go, actually, yeah, I do want to install Git, but you know, I don't think that's too important at the moment. So let me just close. Okay, the thing says instruction says that we need to reboot. So let's just unmount both of these. Actually, you don't really need to unmount, but I just like to unmount it anyway. So let me restart. Okay. So yeah, and you see the restart is very quick. So I'm going to log in to my OpenSUSE, which you can also, yeah. Okay, that's finished. And we are on OpenSUSE. Okay, our Tumbleweed edition. So let's see whether Labview works. Okay, with the new files. So I just click new VI. I'll go to the block diagram. Let's go to control and simulation, and voila, your simulation is over here. So let's just do one example loop, just to convince yourself that this thing really works. Okay, so it will take a while to, of course, to compile and everything, because it's running for the first time. So just wait for it. Okay, so now it's over here, the control design and simulation loop. So this means it's functioning correctly. Now let's just do a while loop here as well. Okay, and let's create a control and stop while loop. Okay, but that's not actually going to stop anything. Okay, and let's also give it a wait time. So I'm just testing various functionality here. Okay, so it will take a while, of course, because it's the first time we are running Labview. Oh yeah, I want to save the VI. Let's put it under documents and let's put Labview. Oh, new folder. Labview. Okay. And we'll put our test 123 OpenSUSE. Okay, so this is test 123 OpenSUSE VI. And let's give it a wait time. Okay, it should be under Express. Okay, where's it? Let's see. Programming timing, yes. There's a wait. So let's just wait for about 50 milliseconds. Okay, 50. Oh, 50. I had my num lock off. So let's do a wait there. And of course, just to test this functionality here, I'll just put what do you call that? Let's put a transfer function here. Yeah, I'll just give it a very arbitrary transfer function. So that will take some time, of course, because you need to actually load in for the first time. So take a while. Transfer function is here, and let's specify our transfer function. Okay, now it's 1 over s plus 1, but I want to change it. Maybe 50 over 50 s plus 1. Okay, let's do that. Okay, so let's put 50. Just change the gain. Maybe make it second order. Okay, 50. Oh, wrong one. Should be the second one. Maybe I'll give it 5s50. Something like that. Okay, I'm not sure what the roots are. So I'm just testing the functionality to see whether the transfer function is working. And of course, to pipe in and pipe out the variables, I will like to use local variables, as I like to do. I mean, yeah. So let's use a local variable, and then we'll just do a let's put a okay. Let's go to the front panel. We'll move the stop while loop here. I'll just do a vertical pointer slide, which we'll just bring in here, and we can just say input control, and I'll shift this here, and I'll change to read. Now I'll do the input control here, wire this in. Okay, and we will have the output here. We'll create a we have to use the control in simulation. Go to simulation and go to graph utilities. Okay, you have to go to the sim waveform part, as I did iterate in some other videos. Sim time waveform over here, and this will be a waveform chart of the output. Okay, And of course, we can wire that in, but before that, I want to do a comparison of the input and output, so I will just do a build array. So the output will go to the top and the input will go to the bottom. Okay, and that's how I will wire. No, don't save. Okay, never mind, forget it. Okay, so let's see whether the waveform chart is. Yeah, the waveform chart is here. Very nice. So I guess that's enough stuff to actually convince us to see whether this thing is working. Put the time as infinite, final time is infinite, run good cutter 1, any infinite check, 0.1 step size, synchronize loop to timing source, 1 kHz clock, and we'll do auto period. Okay, nothing too fancy. This is very basic control VI, CD&Sim VI stuff. Okay, let's close this. And let's turn this thing on. And let's do a input. Yes. And you can see the input is over here in red, and the output will be this this blue curve, which seems to be exponentially increasing more and more. I don't know when it'll stop. It seems to be resting after a while. Yeah, looks like a very underdamped system because it's doing some of the sine wave oscillations. Okay, so if it's doing some sine wave oscillations. Yeah, I don't know what's going on, but long story short, this thing works. Okay, this thing works. So I just bring the output now to 0, and it's going to go all the way down. Okay. So that's basically demonstration of Labview, control design and simulation on OpenSUSE. It was a bit of a headache to try and figure out how this thing runs, but well, yeah, OpenSUSE, Tumbleweed, it works. Alright, so that's all I have. Hope this video was helpful. If you need to, I'm not going to bother. Let me save this and I'll close it. Don't save all. Yeah, so hope this video was helpful in getting you to install Labview 2020 along with the control design and simulation stuff on OpenSUSE. I don't know if you want to try other Linux distros, but OpenSUSE is supported by Labview. Okay, so that's all I have. Thanks for watching. Bye bye.